So welcome once again. We are discussing the topic of forces on the electric charges, and the chapter is electrostatics. So we have discussed what is the force which is acting on a charge when it is near another charge. So we have a question here. This is a square. At the four ends of this, charges are kept in such a way that along this diagonal the opposite ends has charges capital Q and other two are small q. So it is given that force on this charge Q, this or this, is 0, resultant force is 0. Then what is the relation between these two charges? This we have to find. Now before this, let me explain one more thing here, that if we have two charges, then you know that, or two or more charges, then one is applying a force on this and second one is also applying a force on this. This is a charge Q. So another charge Q2 is kept here. So this will experience a force of repulsion or attraction depending upon their sign. So why does this happen? If they are positive charges, then they have electric field produced such that the lines of electric field are moving out of the charge. And if this is a negative charge, in that case these lines will be inside, just like the case of magnets. So charge produces the electric field. Do not get confused with the electromagnetic radiation that is produced by the moving charge. This is electric field. So as a result of this, when this electric field or field lines they interact with this charge, because of this a force is acting on this charge F21, force on 2 because of 1. This is equal to Q2 into E. E is the electric field produced by this. So a force 21 is F21 is acting on this because of electric field produced by this, and similarly this is also producing electric field E. So if the electric fields are same, it may be same or different, but I am talking about the electric field only. Because of this field, this charge is experiencing a force F12 is equal to Q1 into E. There may be E2 and E1, whatever you write. So these are the forces which are equal and opposite. So the answer is that the force is because of interaction of the charge with the electric field. What is electric field? That we will be discussing later on. Now come back to this question. If you take the charge kept at corner B, what are the forces acting? This charge is applying a force on this in this direction. And this is FBA, repulsion. Similarly, this is repelling this in this direction, FCB, FBC. And this charge is applying a repulsion force in this direction, that is FBD. So these two are perpendicular to each other. That means this one is making an angle of 45 degree. This angle is 45 degree. Now you can find the resultant of this. First let us write their values. So FBA is equal to FBC, both will be equal 1 upon 4 pi epsilon 0 QQ divided by this distance A square. And I have written at the magnitude only, direction I have shown here. FB due to this force BD is equal to 1 upon 4 pi epsilon 0 Q into Q divided by A. So this distance is A under root 2. A root 2 equal to 1 upon 4 pi epsilon 0 q square by 2a square. Now what is the resultant force here? First find the resultant of these two which are perpendicular to each other. So F at B is equal to F BC plus F BA these two. These are F. This is F and this is F dash. F at 90 degree. So the resultant will be along the diagonal of this square. If you complete the square along this, so suppose F1 is the resultant. Under root of F square plus 2F cos 90, F under root 2, which is equal to 1 upon 4 pi epsilon 0 q root 2 by a square. Then we have this force F dash. So now F1 and F dash are in same direction, so they can be simply added. So net force on B is equal to F dash plus F1. And this is given equal to 0. So we get so this gives Q is equal to minus 2 root 2 Q. This is the answer to this question. So we can solve the next question now. The next question, we have two positive point charges which are 0.1 meter apart. Let me clean this first. So there are two positive point charges 0.1 meter apart. Repel each other with a force of 18 Newton. F 18 Newton force. Sum of the 9 microcoulomb. Calculate their separate values. Find Q1 and Q2. Suppose Q1 is equal to Q, then Q2 is 9 minus Q. So F is 1 upon 4 pi epsilon 0 Q1 Q2 by R square. So putting the values here, 18 is 9 into 10 raised to the power 9, Q into 9 minus Q, and these are in microcoulombs. This microcoulomb, this. So 10 to the power minus 6 into 10 to the power minus 6 divided by 0.1 whole square. 9Q minus Q square equal to so this is 2 into 10 raised to power this 9 into 2 18 10 20. So we can solve this equation. So Q is (9 plus minus 1 by 2). So you get Q equal to 5 microcoulomb and 4. 5 and 4 microcoulomb. This is the answer to this question. Let us solve some other question now. Now we have the next question. Question is that we have a charge which is divided into two parts, Q and this. A charge total is Q divided into two parts and kept like this at certain distance, and it is given that the so we have to find the ratio of the two parts, Q divided by small q. So first of all, let us write down the expression for the force which is applied by one charge on the another. So F is, they will be applying same force, 1 upon 4 pi epsilon 0. Now you can see here, this is constant, this is constant. The force to be maximum, this has to be differentiated and maximized with respect to this. This is the variable equal to 0. So this gives us d by dq of q minus q square equal to 0, or q minus 2q is 0. So q is q by 2. If you find the second derivative, then this is equal to second derivative of this, q minus 2q. If you put the value 2q here equal to q minus q, this will be 0. That means neither maxima nor minima. The value from this. Otherwise, for maxima, the second derivative should be less than equal to, less than 0 only. So let us assume that here the force is maximum. If you differentiate this second time with respect to this minus q minus 2q, 2q is equal to q. So let us ignore this. So we get q is equal to 2q, or q by q is equal to twice. This is the answer. So the two charges must be, if you put this, the value here of small q, q by 2 and q by 2, equal values, so that the force acting here is maximum between them. Next question, we have three charges. They are kept at the three corners of an equilateral triangle, the side of which is 2a. This is the perpendicular drawn. So you have to find the charge at the force acting on this charge kept at end point A. So find force at A. So at A, the force due to this charge is acting in this direction along this line. This is force of repulsion. This is FAB. Similarly, this charge applies a force on this in this direction, which is FAC. and you have to find the resultant of these two. This angle is 60 degree, so this angle is also 60 degree. So these two forces are equal. Suppose F at an angle of 60 degree. So F is equal to 1 upon 4 pi epsilon 0 q square by 4a square, square of 2a square, sorry, and the resultant force will be in this direction, making an angle 30 degree with this. So Fr is the resultant force. You can see only two charges are applying force on this: repulsion, repulsion, along this, along this. Under root of f square plus 2ff cos of 60 degree. F square plus f square plus f square cos 60 is 1 by 2. F under root 3. So this is 1 upon 4 pi epsilon 0 q square root 3 by 4a square Newton. In the direction perpendicular to the base or along perpendicular bisector of the base, making an angle 30 degree with any of these two forces. So you can check yourself that if any of these two charges or these three charges changes, suppose it becomes positive to negative, then how will the direction of the forces change? So these are some of the questions which we have solved for calculating the force on the charges. So if you have any doubt, then please write to me in the comment box, and if you like it, then please subscribe and share the channel. Thank you very much.